Okay, so once we start answering questions, we are going to again consider this in three cases. Now you always know I like to refer to things in cases. We are going to consider momentum into three different cases. And so we say the following: the total momentum of a system is the total momenta of each of the objects in the system, or rather is the sum, let's change that word, is the sum of the momenta of each of the objects in the system. And then finally, when we have an isolated system, we say that the total momentum is always conserved. That is based on the principle of conservation of linear momentum. Right, I've already done the intro explanation with you, and there's the formula for the momentum of an object. Momentum of an object. Right, so let's start looking at the first case. Okay, so let's take notes and make sure you're working with me. Case 1. Case 1 is where we will consider a collision, right? Okay, but a specific collision. We say that the objects are separate before and separate after. They are separate before and they are separate after. So what does this mean? This means the following. I've got an object. I've got object A that goes there, and I've got object B, and they knock into one another. And this is before the collision. After the collision, the following happens. A moves that way and B moves this way. And that is what things look like after. Okay, so let me tell you, this will be our case 1, right? So case number 1 will have the following. We need to say, well, applying the law of conservation of momentum, it says that P final is equal to P initial, or P before is equal to P after. That is really the law of conservation of momentum, because you say before minus final, I'm going to get 0 if I take that over, or I say the final minus the initial, I'm going to get 0. That means that there was no change in the momentum before and after. And again, we're looking at the momentum of the system. Okay, so let's put a big, let's leave that, let's make this black. Actually, let's put it in red, but let's just bring up a shape. Let's bring up a rectangle and say that we are going to draw something for that part, and then we're also going to do something for this part, right? The before part and the after part. So let's take the momentum before and let's do it in here. I'm going to say before okay, my case 1 formula will be the before side. I'm going to say, and this is how you should do it. You do it exactly as is. You say mv plus mv is equal to mv plus mv. Right, now you start filling in things. You say, well, this is the velocity of A and the mass of A, and this is the mass of B and the velocity of B, and this is of A, and this is of A, and this is of B, and this is of B. Then you say, well, this is in the before side, so I put the initial, and I put the initial, and then I say I put here final, and I put here final. And this is your case 1. Make sure you got it down. It is where we have two objects colliding, and then they separate. Okay, before the collision they go boom, and then they knock each other and they move off again. And this here will be the formula that you will use for case 1. This thing over here. Okay, this is the formula for case 1. So learn how to set it up. You say momentum of that plus momentum of that gives me the momentum of the system. Then label it AA, BB, initial, initial, AA, BB, final, final. That's how we work. We work with the system. Okay, so let's